Hi guys, today we'll start with the functions. So in the last class I sent them notes on this topic, that is the functions and few types of functions and their graph also. So those are important for a 5-mark question, that is the graph. So before that, so let me explain the definition of the function. So here the function is nothing but a relation f from set A to set B is said to be function if every element of set A has one and only one image in set B. Let me clear this definition by taking an arrow diagram. Okay, so here is set A. I'll just take, and this is what is set B. Here are the elements like 1, 2, 3, and here I'll take 4, 5, 6, 7, some numbers like this. So there is a relation between the set A and a set B. We need to call a relation is a function when a set A to set B is said to be a function if every element of set A has only a one image in a set B. Is nothing bad. Here is a relation and which is mapping like this. Okay, this is what the relation. Okay, each and every element of set A has an image in a set B. Okay, and I'll call this is what the relation, and hence I'll call it this relation is a function. Is it clear? When we will call the relation as a function is nothing but which is a mapping from set A to set B, and if every element of set A has only a one image in a set B. For example, you may take it this 2, it may be mapped with a 7 if you take it. Okay, this is a one scenario. If I take for this element we have a 2 image in a set B. So in that case, this is not a function. It may be a relation, but this is not a function. Hope you guys understood now. Each and every element of set A, there should be a one image in a set B. Then only we will call this relation as a function. Okay, so this is a function. Now, I'll just take one example and let me clear this definition. So here, let n be a set of natural numbers and the relation R is defined on the same natural number such that the relation which is like x comma y and y is equal to 2x, where x and y is belongs to natural number itself. Okay, the question is whether this relation is a function or not. We need to check. Okay, so since this y is equal to 2x, okay, if I take x elements, because it is in natural number, even y is also in a natural number. If I start with x values is a 1, 2, 3, so on infinity, because there is no limit for this natural number in this relation, then if I take x is a 1, then y will be 2 into 1 is nothing but 2. Is it clear? If I take x is a 2, y is equal to 2 into 2 is equal to 4. Okay, it's a so on. It is a infinity. It's nothing but y is a multiple of a x, and all the multiple of a 2, it will be there in the natural numbers. Okay, so now x is a 1, then y is mapping with a 2. When x is a 2, it is mapping with a 4. If x is a 3, it is mapping with a 6. but for 1 we will not get it like a 4, right? So this is what the relation for this condition, and each and every element of a x, for this x we have a unique image in a y, is nothing but this multiple of a 2. Therefore we will get a one and only one image for this x, and we can call it this relation is a function. Hope you guys understood this. Okay, so I'll just tell you the reason that since the set of natural numbers, so here every natural number n has one and only one image, therefore we can say that this relation is a function. Okay, so now I'll just go with the next one, which is like an ordered pair. So if the relation is like directly it is in a ordered pair, then how can we say that that relation is a function? Okay, so examine each of the following relation given below and state in each case, giving a reason whether it is a function or not. I'll just take the relation 2, 1, 3, 1, 4, 2. We need to check whether this is a relation, this relation is a function or not. Since 2, 3, 4 are a x element if I take, okay, then 1, 1, 2 are the elements of a y. So here is a function definition when it is in an ordered pair. Okay, I'll just tell you the other definition for a function. A function is a relation from non-empty set A to non-empty set B such that domain of f is A. No two distinct ordered pair of f have the same first element. So when the relation which is like a ordered pair, you need to check with the first elements in each ordered pair. So in this ordered pair, so there is no two ordered pair is with the same first element. If it is the same first element, what you'll get is, so here I'll just go with the arrow diagram for this. Okay, so first element you can take a and the second elements in each ordered pair you can take it as a b. So in this 2, 3, 4 is there, it is from the first set 2, 3 and a 4. In a second set, the second element which is 1 and 2 is there. So 2 is mapping with a 1, then 3 is mapping with a 1, 4 is mapping with a 2. Okay, so in a first set, each and every element there should be a image in a B. Okay, but don't confuse that. So here is this 2 as the image in a B with a 1, 3 is also image with a 1. Okay, don't confuse with that. So if it is 2 is image with a 1 and 2 is also image with a 2, then you can say that this is not a function. But for each and every element of A, there is an image in a B and it is only a one image. Okay, so when the relation is like an ordered pair, you need to check with the first element of each ordered pair. So first element of each ordered pair should be a different, then only you can say that this relation is a function. If it is a 2, 2 itself in this relation, then it is mapping with here also. So for this one element, we have a two different image in a B. In that case, this is not a function. Okay, hope you understood this. Next, I'll just take it the second one. Our relation is 2, 2, 2, 4, 3, 3, 4, 4. If I go with the arrow diagram, it will be easy. So first elements are like 2, 2, 3, 4 is there. 2 is repeated. I'll just write it only once. 2, 3, 4. Second is 2, 4, 3, 4 is there. Again the same 2, 3, 4. I'll just take it. 2 is mapping with a 2. Next 2 is mapping with a 4 also. 3 is mapping with a 3. 4 is mapping with a 4. So can we say that this is a function? No, this is not a function. For each and every element of a set A, there is an image, but for this element we have a 2 different image in a B. In that case, this is not a function. That means when the relation which is like a ordered pair, you need to check with the first element of a ordered pair. So first element of a ordered pair should be a different. If it is a 2 ordered pairs of a first element is the same, by that only you can say that this is not a function. Okay, it may be a second element, it may be a repeated, but the first element of any 2 ordered pair is the same means you just write it directly, it is not a function. Okay, so I'll just take it the last one. So R is 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. If you check with this relation, the first element of each ordered pair are a unique, okay, different. So the second element also a different. So hence you can say that this relation is a function. I'm not writing the answer for these questions properly because I sent the notes in that, examples are there. So I'm just explaining what I did in that notes, okay? So next is some functions and their graphs is there, and that is important for a 5 mark. Any one graph they'll ask in the exam for a 5 mark. So first one is some functions and their graphs. First one is identity function. How you are going to answer for such a question is nothing but they'll ask a define identity function and plot the graph they'll ask, and also they'll mention it, write the domain and a range. In that case, you have to write the definition for this, write the domain and a range, then construct a table, and for the table you just plot it on graph. So each and every step it carries a 1 mark. So first is the definition. Identity function is nothing but, let's take R be the set of real numbers, then the function is mapping from real number R to R. Hence the function is y is equal to f of x is a x itself. Okay, and such a function we'll call it as identity. So in a definition, this condition is a compulsory. Okay, you can write your own definition, is nothing but in your own words, but this condition is a compulsory. Okay, I will write the definition is nothing but, let R be a set of real numbers, then the function f is mapping from R to R such that y is equal to f of x is nothing but a function which is equal to x itself. Okay, then for each x is in a real number, then such a function is called as identity function. So your domain and range of a f is R itself. So both domain and range is R, and this graph is a straight line passing through the origin, is nothing but, I'll construct a table, then you will come to know what exactly this identity function. Here you will take x values, then y values will be this x itself. So this is called as a identity. Identity is nothing but whatever the values you will take for a x which is same for the y is nothing but the function values, and this condition will call it as identity. If you take -2 as a x, then y value is also -2, then x is a -1, y is also -1, x is a 0, y is also 0, x is 1, y is also 1, and the last I'll take it, if x is 2, y is also 2. So now you just plot the graph for this. There's nothing but you just plotted all the 4 quadrants. This is x, x dash, y, y dash, 1 and 2, minus 1, minus 2, minus 1, minus 2, plus 1, plus 2. So whatever the values you will take for x, which is same as a y for the identity. If x is a 0, y is also 0. If x is a minus 1, y is also minus 1. If x is minus 2, y is also minus 2, somewhere here. When x is plus 1, y is also plus 1. When x is 2, y is also 2. You just join it. Therefore, the graph, which is like a straight line passing through the origin. So this straight line, you need to mention it, y is equal to x. This is what? Identity function. So you just mention it in a graph itself, that is the domain is a real number. The range is also real number. Is it clear? So this is what the identity function. Identity is nothing but whatever the values you will take for a x, which is same for a y. Okay, we'll just do it the last one. Okay, we have actually 6 functions are there, but out of 6 I'll do today only a 2. Remaining 4 will do it in the next class. That is the second function, which is a constant function. Write the definition first, then construct a table, plot the graph. At the last you just write it, domain and a range. So constant function is nothing but it is a function f mapping from R to R. Then the function is defined by y is equal to f of x, and this is what? A constant. Constant is nothing but you can take any values, and this x belongs to real number and c is a constant, and here the domain is okay. Before explaining a domain and a range, let me construct a table and I will plot the graph, then you will come to know what exactly this domain and a range. Okay, the definition of a constant function is what? It is a function is a f from R to R. Y is equal to f of x is equal to c is nothing but constant. It is x is in R and c is a constant, again it is in a R. Now I'll take the table x and the function is a c, which is a constant. This constant you can take any values. I'll just go with a 2. Okay, you can take any values. You may take it is a 0, or you may take it is a plus 1, or you can take it is a minus 1, whatever the element, and it is a constant for all the values of x. Okay, that's it. So I'll just take it, this constant value is a 2. Okay, so if I take x value is a minus 2, y is a 2 itself, x is a minus 1, y is also plus 1 again. If x is a 0, y is a 2 again. When x is a plus 1, y is a 2. When x is a 2, y is also 2. Is nothing bad. The values of the function is a constant. That value you may take it your values. Okay, is nothing but any negative, any positive you can take. Okay, not only a 2 it is. Sometimes they'll mention it in a question itself. Define a constant function and the function is a 3. Function is a 4. They'll mention it. Okay, you need to read the question properly. Sometime they'll give you the constant value. Okay, in that case you need to take that value only. Okay, so now the graph will be, it is a x, x dash, y dash and a y. X is a 1, x is 2, minus 1, minus 2, minus 1, minus 2, 1 and a 2. Now when x is a 0, y is a 2 it is. When x is plus 1, y is plus 1. When x is 2, y is a 2. When x is minus 1, y is a 2. When x is minus 2, y is minus 2. you will get a straight line which is parallel to x-axis always. You may take any values. It may be a 1, it may be a 2, it may be a -1, it may be a -2, whatever the value. So whenever the function is a constant, then you will get the graph which is like a straight line which is parallel to x-axis. So y is equal to constant and that value is a 2. So now you just tell me the domain. So domain is nothing but x values, and all the x values you will just take it from the real number, therefore it is R. Range is nothing but what? Range depends on the function values, that is a y. So therefore this range is depends on the constant, that is a c. Is it clear? And you can write that constant value is a 2, that is a 2. So domain is nothing but x values, range is nothing but y value. Okay, so this is about the constant function. So remaining 4 functions we'll just do it in the next class. Hope you guys understood the function and the identity function and a constant function. Okay, thank you guys.